Hello everyone and welcome in a new video, and in this video we are going to understand about SRTF scheduling algorithm. SRTF means shortest remaining time first scheduling algorithm. Okay, so this scheduling algorithm is different from the other two scheduling algorithm which we understand like FCFS and SGF. Okay, these two processes are of non-preemptive type, but SRTF is a preemptive type. So definitely we understand a lot of things in this video, so be till the end. So let's start this video. SRTF. So SRTF means shortest remaining time first. It's like a big brother of SJF, shortest job first. Why I said this thing? Because all they do the same thing but in a preemptive way. What does this mean? Let's understand this thing. So but first of all, what is it? Scheduling criteria. Scheduling criteria is very simple. Whosoever ever smallest burst time will get a CPU first, like in SJF. So smallest burst time will get CPU first. Smallest burst time will get the CPU first. Okay, so after that, so this is like similar like SGF, because SGF is also those who have a smallest burst time will get the CPU first. The same thing is happen here. In case of tie, when there is a tie between the burst time, what you have to do? You have to do what you do in FCFS. Do what you do in FCFS. What we do in FCFS, those who have a smallest arrival time will get the CPU first, or you can say those who come in first in the CPU will get the CPU first. Okay, now the type of algorithm. This is a preemptive type of algorithm. What is the meaning of a preemptive? Preemptive means now operating system have a power to snatch the CPU from a running process. This is what not happening in the case of FCFS and in the case of SJF, but in this scheduling algorithm this thing will happen. Operating system snatch the CPU when he see that there is a other process who basically fulfill the requirement. Okay, let's see this thing with the help of example, that how we solve SRTF problem. Okay, so we have a processes, and the process is like P1, P2, P3, P4, P5 and P6. We have a 6 process whose arrival time is 0, 1, 2, 3, 4 and 5, and whose burst time is 8, 5, 1, 2, 1, 4. So this is what a question, and what you do is simple. What we do in every questions, we have to find the average TAT and average waiting time. So for that we have to find the completion time, we have to find the turnaround time, we have to find the waiting time. Okay, to solve this question, what you have to do is you have to make a rough block as well. Why I say that? Because we are solving this question because we have to do so many operations here. We have to do subtraction so many times, because the switching between the process is taking place, because it's a preemptive algorithm. So operating system will snatch CPU from a running process, give CPU to another. So there is a subtraction in burst time. So burst time calculation block you have to make. This block is a rough block, so definitely if you solve this question for your college exam, so what you do, you have to do it in a rough, not with this same page. Okay, so how we solve this question? Burst time 8, 5, 1, 2, 1, 4. Now to solve this type of a question, what we have to do is, first of all we have to make a Gantt chart. Okay, so Gantt chart is look like, okay, so Gantt chart is look like this. Okay, so 0. Now at 0, at arrival time 0, how many processes are there? Only one process, P1. So if there is only one process, so there is no confusion, so we have to assign CPU to that process. In non-preemptive case, what we do is we completely run a process. But in a preemptive case, what we are going to do is we are going to run it at 1. Why I say that I run it 1? Because after 1, when there is arrival time 1, we have two processes available, P1 and P2. We have two processes available, P1 and P2. Now we have to choose between the processes whose process will get a CPU. This is what we do in a preemptive thing. Non-preemptive, the process get a CPU will execute full in a go, but this thing not happen here. So you execute from 0 to 1, you only execute 1, so subtract 1 from 8, you will get 7. Okay, and now you have two choice, P1 and P2. So SRTF means shortest bus time will get a CPU first. So between these two processes, P1 and P2, who's having a smallest bus time will get a CPU first. So the P1 process bus time is 7 and P2 process bus time is 5. Now the update bus time is basically seen to assigning a process. Now we are not gonna see BT from this one. We are in a calculation part, we are seeing that which process is there. So between these two, 5 is smaller, so definitely P2 will get a CPU, but for how much time? For till the next arrival time. So next arrival time is 2, so definitely it also run once, so 1 plus 1 is 2. P2 is also run 1, so 5 minus 1 become 4. Okay, so 5 minus 1 become 4. After that too, we have three processes available, P1, P2 and P3. So who's having a smallest bus time will get a CPU first. So among these three processes, definitely P3 is the one who having a smallest bus time, so definitely run P3, who's till the next arrival time, which is 3 means 1, and the bus time is also 1, so definitely you execute only 1, so it become 3. 1 minus 1 0, so P3 executes successfully, PC executes successfully. Now at 3 arrival time, how many processes are available? P1, P2 and P4. 3 processes are available. So who's having a smallest bus time will get a CPU. So P4 is a process who having a smallest bus time, so P4 will get a CPU for 1, because at 5 we have another process is available. So you add only 1, you execute the P4 is execute once. So P4 from 2 it become 1 and it become 4. So at 4 we have now P5 processes also available. So P1, P2, P4 and P5, 4 processes are available to get a CPU. So whosoever is the smallest burst time will get a CPU. So P4 is a process who have a smallest burst time. Okay, so if this process have a smallest burst time, then we have to select this process. Okay, P among these 7, 4, 1 and 1. So here you can see that there is a tie between these two processes. So when there is a tie, what we have to do, we have to select those process according to FCFS scheduling algorithm. So whose process come first will get a CPU first. So among P4 and P5, 4 is smaller, so definitely P4 is selected. So P4 not run for 4, it run for 5. Okay, so it run for 5. Okay, it run twice. So now this thing also run, P4 process is also completed. After 5, at 5 arrival time, now P6 process is also available to execute. So how many processes are available? P1, P2, P5 and P6. 4 processes are available to execute. So whoever is smallest burst time will execute. So here you can see that now arrival time is over, so the process will execute full in a one go. So P5, how much value is 1. So P5 will get a CPU and it execute from 5, it becomes 6. Okay, so P5 is execute, only 3 processes are available. So among these 3 processes, 5 and 4, which now 4 and 4, so there is a tie between these 2 processes again. So who come first will get a CPU first. So definitely P2 and P6, which process will come first in a ready queue? P2. So P2 will get a CPU and its value is 4, so 6 and 4 10. After that P6 14, and after that the last process which is P1 and the value is 7, so 7 and 14 it become 21. So all these processes are now execute and we make a Gantt chart. Okay, after that what you have to do is you have to write the completion time, TAT and WT, and you will get your answer. So this is an easy thing, you can do it by yourself. Let's do it. Pause the video and do it and comment down your answer. Okay, so now let's do this thing. P1, completion time of P1, you have to see from the right side, not from the left side. At right side the process occur, what is it completion time? write this. So P1 completion time is 21, so for P1 21, P2 10, P2 10, P3 it's 3, P4 it's 5, P4 P5 it's 6, P6 it's 14. So these are the completion time. Now TAT is what? TAT is completion time minus arrival time. So it's 21, 9, 1, 2. Okay, so 2, 6 and 4 is 2 and it's 9. So the completion time is 21, 9, 1, 2, 2, 9. And waiting time is what? Waiting time is turnaround time minus the burst time, TAT minus BT. So 21 minus 8, 13 and 4, 0, 0, 1, 5. So this is what WT. So now you can easily find average turnaround time, the sum of all the TAT and divided by the number of processes. 21, 9, 1, 2, 2, 9. It's become 44. 44 divided by 6. 44 divided by 6. So what is the value? 44 divided by 6. So the value is 7.3. And average waiting time. What is the average waiting time? You have to sum up all these. So the average turnaround time is 7.3 and average waiting time is 3.8. So this is what the solution of this question. Okay, so I hope you understand the concept of SRTF, that how we are going to solve this, how we are basically solve this question. Okay, now we are moving towards the next question. So the next question is, we have a process P1, P2, P3, P4, P5, 6 arrival time and a burst time. What we have to do is we have to find the same thing, average turnaround time and average waiting time for this process. Okay, so for that what we have to do is, first of all we have to find out the completion time, we have to find out the turnaround time, we have to find out the waiting time, and one block is for burst time calculation. One block is for burst time calculation. Okay, so this is the question. Now pause the video and try to solve this question by yourself. After that resume the video and see the answer. Okay, so I try to solve this Gantt chart. So we now, first of all what we have to do is we have to create a Gantt chart. So we have, in this question we have 6 processes. So at starting point 0, how many processes are available? Only one process, P6. So definitely it will get a sorry, so definitely it will get a CPU. So P6, okay, how much time will P6 will get a CPU? Only for 1 unit of time. Why? Because at one arrival time we have 2 processes available, P4 and P6. 2 processes available, P4 and P6. Okay, so burst time is 7, 5, 1, 2, 1, 4, and I run P6 once, so it becomes 3. Okay, after that at one arrival time we have 2 processes, P4 and P6. So whosoever have a smallest burst time will get the CPU. So P4 have a smallest burst time, so definitely it will get a CPU, P4. So for how much time? For till 2. Why? Because at 2 we have 3 processes available, so we have to select the process in these 3. Okay, so P4 is also run at 1, so it become, the value become 1. The burst time of P4 left is 1. Okay, after that now we have 3 processes. Now whosoever have a smallest burst time will get the CPU. So in these 3 processes there is a tie between P4 and P5 because they are having a smallest burst time, 1 and 1, and there is a tie between these burst time. Then what we have to do is we have to select the process who come first in a ready queue. Okay, so this is what happened in FCFS, and if there is a tie then we have to follow the FCFS rule. So whosoever have a smallest arrival time will get the CPU. So between P4 and P5, P4 have a smallest arrival time, so definitely P4 run one more time. So from 2 it becomes 3 and P4 is now completed. P4 is now completed. After that, after P4, now the arrival time is 3. So at 3 now we have 3 processes available, P3, P5 and P6. 3 processes are available. Between these 3 processes we have to select who have a smallest burst time. So here you can see that there is a draw there is a tie again between the process P3 and P5. So whosoever has smallest bus time will get the CPU. So if there is a tie, then what we have to do is we have to select the process who have a smallest arrival time. So P5 have a smallest arrival time because P3 is 3, 80 of P3 is 3 and 80 of P5 is 2. So it become, so the process who get a CPU is P5 because of arrival time. And how much time will P5 execute? Only once, because at 4 we have one more process available, P1. So it only run once and the bus time is also 1. So P3 is also completed. At 4 now we have P1 process also available. So P1, P5 and P5 not P3. P1, P3 and P6, these three processes are available to execute to get a CPU. Now between these three processes, whosoever has the smallest bus time will get the CPU. So definitely P3 is a process who have a smallest bus time 1. Okay, so we have to execute P3. So P3 will get a CPU till 5, mean it only execute 1 because its bus time is 1, and at 5 we have one more process available which is P2. So P3 is also executed. Now at 5 arrival time we have now 3 processes, P1, P2 and P5. These 3 processes are available. Now after 5, here you can see that there is no more arrival time. So whosoever process get a CPU, they execute whole in a one go. There is no context switching right now. So between these 3 processes, whosoever have a smallest bus time will get the CPU. So P6 is a process who have a smallest bus time which is 3. So 5 and 3 is 8, and P6 process is also completed. P1 and P2 have a smallest bus time, so P2 will get a CPU, and the bus time is 5. Bus time is 5. So 8 and 5 become 13, and after that P1 process available, bus time is 7, and 13 and 7 is 20. So Gantt chart is look like this. Gantt chart for this particular question is look like this. Now it's easy to find the completion time, turnaround time and waiting time. Okay, so what is the completion time of P1? 20, completion time of P2 13, completion time of P3 5, P4 3, P5 4 and P6 is 8. So 20, 13, 5, 3, 4, 8. T80 is what? Completion time minus arrival time. 20 minus 4, it becomes 16. 13 minus 5, 8. 5 minus 3, 2. 3 minus 1, 2. 4 minus 2, 2. 8 minus 0, 8. So this is what the turnaround time. After that, waiting time is what? Turnaround time minus the burst time. This is what a waiting time is. So 16 minus 7, 9. 8 minus 5, 3. 2 minus 1. 2 minus 2. 2 minus 1. And 8 minus 4, which is 4. So this is what a waiting time is. Now it's easy to find out the average turnaround time and average waiting time. So average turnaround time is what? The sum of all TAT divided by the number of processes. 16, 8, 2, 2, 2 and 8. So it become so the TAT will become 38 divided by the number of process. 6 processes there, so it becomes 6.3. So average turnaround time will become 6.3, and average waiting time is like 93114. So it becomes 18 divided by 6, so it's 3. So on an average the process have to wait 3 unit of time, and on an average the turnaround time of a process means the time process spent in the CPU is 6.3 unit. So I hope it is clear to you that how we are solving these questions. Okay, it's a very easy type of question, so I hope you understand this thing. Now what after that, what we have to do is we have to understand about the advantages and the disadvantages of this particular type of scheduling algorithm, which is SRTF. Okay, so now we understand about the advantages and the disadvantages. So what is the advantages of turnaround time? Let's first of all understand this thing. Okay, so
So the advantages is that it gives us a minimum average waiting time and minimum average turnaround time among all the scheduling algorithm. Means whatever scheduling algorithm we have, FCFS, SRTF, HLNR, priority, feedback, whatever algorithm we have, if we collect all the algorithm and try to find out the minimum TAT and minimum WT, because CPU scheduling is what? The purpose of CPU scheduling is to get the minimum turnaround time and minimum waiting time and high throughput. So this algorithm basically do that thing. Okay, it provides minimum turnaround time, it provides minimum waiting time among all the scheduling algorithm. So many times the question arises like this, that solve this a particular question. Here you can see that this is like a question. So many times the question arises like this, solve this particular question with those algorithm who gives minimum average waiting time and average turnaround time. So it's here you can see that there is no scheduling algorithm written in a question. So you have to think by yourself that which scheduling algorithm we need to apply here. So if there is nothing given, then you have to use SRTF, and the question is like this: you have to solve this by non-preemptive scheduling algorithm. You have to find the minimum turnaround time, minimum waiting time by non-preemptive scheduling algorithm. Then what you have to do is, then you have to solve it by SJF, and it says that solve this with the preemptive algorithm and give minimum turnaround time and minimum waiting time. Then you have to solve it by SRTF. And if in general you ask, then also you have to solve this by SRTF. Okay, so this is what the advantage is. So what is an advantage? Minimum average waiting time and turnaround time. Minimum average waiting time and minimum average turnaround time among all the scheduling algorithm. Among all the scheduling algorithm. Among all the scheduling algorithm. This is what the advantage of SRTF. And what is the advantage of SRTF? It gives us a better throughput in a continuous run. So it gives us a better throughput in continuous run. What does that mean? That means if process is coming in a ready queue, it will get a CPU, it execute. Means CPU is not becoming an idle. The process always come in a CPU. So this is what the meaning of a better throughput in a continuous run. Okay, so this algorithm gives us a better throughput. But what is its disadvantage? If you talk about the advantage, here you can see that we talk about advantage, then everything, whatever the goal of CPU scheduling, it basically do that thing. So this algorithm is the best algorithm, but no, there is a disadvantage of this algorithm as well, and that's why this algorithm is not enough use. So what is the disadvantage? Disadvantage is that there is no practical implementation of this algorithm. This algorithm is used nowhere. Okay, so there is no practical implementation. Advantage is this: there is no practical implementation. This algorithm is used nowhere. Why? Because of its burst time. Because the burst time. Why I say this thing? Because if algorithm, let's say this is our CPU, and this is our queue. This is our ready queue. So in ready queue we have a processes P1, P2, P3, P4. We have, let's say, 4 processes available in a ready queue, and we have an operating system. What happen is, because operating system does not know about the process burst time. So if operating system does not know about the process burst time, then how we can implement this algorithm to any system if we don't know that this process is run at what amount of time? Let's take an example to understand this thing more clearly. you are using your phone, you open a WhatsApp and your mom's call you, then what you do? You simply terminate the process, terminate the current process, you delete your WhatsApp. Basically you swipe up the WhatsApp and you terminate that WhatsApp process. Okay, after some time when you're free, so you open WhatsApp and you spend around 30 minutes on your WhatsApp. At starting, few minutes later, at starting when your mom's call you, you spend only 1 minute on WhatsApp, and after that you spend 30 minutes on a WhatsApp. Okay, so how operating system determine, how operating system find out that okay, what is the burst time of this particular process? It cannot, because it depend on you and you are continuously changing it thing. So definitely operating system cannot understand this thing. So that's why there is no practical implementation, because operating system does not know about the burst time, does not know about the burst time. That's why this this algorithm is not in a practical use. Okay, so burst time is not known in advance. Burst time is not known in advance. So that's why this process have no practical implementation. What is the disadvantage? In this scheduling algorithm, longer process may suffer from a starvation. May suffer from starvation. Why I say this thing, this process suffer from a starvation? Because here you can see that this process choose those process who have a smallest burst time. Let's see, the burst time of P4 is 100 and burst time of P1 is 10, burst time of P2 is 5, burst time of P3 is 20. So what it does, it first of all provides CPU to P2 and then provides CPU to P1. In between these things, what happen is after completion of a P2 there is a process, let's say P5, who come, whose burst time is also 5. After the completion of P1 there is a process P6 who come in a CPU and whose burst time is 2. So what happened, after completion of a P1, P6 will get a CPU, after that P5 will get a CPU, after that P3 will get a CPU. In between these things what happen is, so because these blocks become empty after termination of a process, this block become empty. After that what happened, P7 and P2 block were acquired by P8 and P3 block were acquired by P9, and whose burst time is also smaller than the P4. Okay, so let's say 5 and 2. So definitely P4 will not get a chance to get a CPU. So here now what happen is, P4 will get a CPU, then P7, then P8. In between these things new process also coming. So those process who have a larger burst time may suffer from a starvation, will get a CPU at an indefined amount of time. We don't know that when this process will get a CPU. So there is a problem in this scheduling algorithm, that the process may go in a starvation. So that's why there is an disadvantage as well of this algorithm. That's why this algorithm is not in a use, because disadvantage is very greater than the advantage. So then why we understand this algorithm? So many questions are arising in your mind, that why we understand this scheduling algorithm. So the answer is, it's create a benchmark for the other scheduling algorithm, other practical scheduling algorithm, because we have so many scheduling algorithm and we find the average waiting time, average turnaround time, and we compare with this algorithm SRTF, and when we compare it with other algorithms, then we understand that which algorithm is better in a practical use, because we have so many algorithms. So we compare the average waiting time, average turnaround time with SRTF, and understanding that okay, this algorithm is better, so we can implement this algorithm in our system. Okay, so SRTF create a benchmark for the other scheduling algorithm. So this is what SRTF, advantage and disadvantage, SRTF, how to solve the question of SRTF. Okay, so thank you for watching this video. Like the video and subscribe my channel.